Welcome to this explainer. Today, we're taking some highly technical manufacturing data and translating it into the fascinating story of how raw materials become the armchair you might literally be sitting in right now. You know, when we look at a piece of furniture, we usually just see the finished product. But behind that smooth fabric and sturdy frame is this highly orchestrated symphony of heavy machinery, precise computer coding, and raw industrial materials.
So, what does it actually take to build the perfect armchair? Well, let's dive right into that and uncover the intense precision, tooling, and technology hidden beneath the surface of everyday furniture. It is incredibly easy to take our everyday environment for granted, but once you understand the sheer amount of engineering required just to give us a comfortable place to sit, I'm telling you, you're never going to look at your living room the same way again.
Okay, here's our roadmap for the factory floor today. 1. Anatomy of an armchair. 2. Crafting the structural frame. 3. Shaping the foam cushions. 4. Tailoring the upholstery cover. And finally, 5. Final workbench assembly.
Let's kick things off with Part 1, Anatomy of an Armchair.
Right, so before we fire up the massive industrial machines, we need to gather our raw materials. Every great piece of manufacturing begins with a precise inventory, kind of like a foundational recipe that dictates exactly what enters the production line. And these raw materials right here, they're going to serve as the skeleton, muscle, and skin that eventually become our unified piece of furniture. Notice the specific choices we've got. We aren't just using generic wood. We have heavy-duty birch plywood for the structural legs and support, paired with some really beautiful solid beech lumber for the armrests. The comfort comes from a very specific PU foam, the T3028, and the whole shebang is going to be wrapped in a classic corduroy fabric.
Moving right along to Part 2, Crafting the Structural Frame.
This is where heavy woodworking meets raw timber. It's definitely the loudest, dustiest, and arguably the most vital part of the factory floor. Because without a perfect skeleton, everything else just falls apart. 28 millimeters. That is the exact thickness of the heavy-duty birch plywood used for the right and left legs of this specific armchair. Now, why does that specific number matter? Because 28 millimeters gives you incredible structural rigidity, ensuring your chair never warps, cracks, or wobbles, even after years of daily use.
Now, to tackle waste, CNC machine tools use this brilliant process called nesting. Think of it like a highly advanced automated game of Tetris. The computer calculates exactly how to map out and cut those 28 millimeter thick plywood boards using profile end mills so that virtually every single square inch is used. It slices out the right and left legs with just absolute robotic precision.
Meanwhile, the solid beech lumber for the armrests goes through its own rapid, sequential gauntlet of cuts and shaping to reach its final elegant form. See, unlike the plywood, which is just cut from flat sheets, this solid timber has to be ripped to the proper width and cross-cut to length. Then, it gets sent through a double-sided planing machine just to get the raw wood completely flat and uniform before it's finally molded into shape.
And listen, those initial ripping and cross-cutting steps, they are absolutely not delicate operations. We are talking about massive 400 millimeter circular saw blades literally tearing through the solid beech. These multi-rip and cross-cut circular saws spin at blinding speeds to easily slice right through that dense hardwood, prepping the solid pieces for the refinement stages.
But of course, after all those aggressive 400 millimeter cuts and powerful planer cutter heads do their job, everything gets smoothed out beautifully. The parts are run through wide belt sanders equipped with a specific P120 abrasive belt. This removes all the rough tooling marks and leaves the wooden legs and armrests perfectly smooth and ready to be touched by the end consumer.
All right, let's jump into Part 3, Shaping the Foam Cushions.
Next up, we get to leave the sawdust behind and look at the components that actually make the seat comfortable. We're essentially moving from the skeleton of the chair to the muscle. This specific standard polyurethane foam block, the T3028, serves as the core cushion insert. And you know, in the manufacturing world, foam isn't just foam. It's carefully formulated for specific densities and rebound rates. The T3028 provides the perfect balance. It's soft enough to be inviting, but dense enough that it definitely won't flatten out after a few months of movie marathons.
But how do you accurately cut giant blocks of squishy material? Well, instead of simple manual blades, CNC machine tools guide this massive carousel foam cutting bandsaw to carve the foam blank into the perfect seat and backrest cushions. This machine allows for incredibly fluid, continuous, computer-guided cuts right through the thick PU foam, ensuring every single cushion insert perfectly matches the required blueprint dimensions.
Which brings us to Part 4, Tailoring the upholstery cover. Let's transition from the foam inserts to crafting the exterior skin of the chair.
This is where industrial manufacturing meets the absolute precision of a master tailor. The process kicks off with massive rolls of corduroy fabric, measuring 160 centimeters wide. Guided by digital pattern templates, a robotic CNC fabric cutter using a drag rotary knife cleanly slices the fabric into perfectly sorted pieces. It's fascinating because this completely replaces the old-school method of chalk outlines and hand shears, cutting out pieces for the seat, backrest, and arms with absolute consistency every single time.
Now, you can't just use a standard needle and thread for furniture, right? To make sure these seams can withstand years of daily sitting, pulling, and shifting, the factory relies on some serious gear. Industrial upholstery sewing machines, specialized thick machine needles, and an incredibly strong, heavy-duty polyester thread to stitch those final covers together.
And that leads us to our last step, Part 5, Final Workbench Assembly.
We deliberately slow things down here, as all our freshly crafted components, the sanded wooden frames, the CNC-cut foam, and those heavy-duty corduroy covers, arrive at their final destination, the upholsterer's workbench. First, the structural frame is pieced together. The right and left side frames are locked into place using classic PVA wood glue to bond those elegant solid beech armrests directly to those 28mm thick birch plywood legs we saw earlier. Even with all the high-tech machinery we've talked about, traditional PVA glue remains one of the absolute strongest and most reliable ways to join wood pieces permanently.
Then, with a quick, powerful burst of compressed air, a pneumatic screwdriver fastens those newly glued side frames to the 16mm birch plywood support boards. These support boards are basically the critical bridge between the left and right sides, locking everything into a rigid, unified skeletal frame that is now completely ready for upholstery.
Over at the upholstery station, things are coming together just as quickly. Contact adhesive is applied to guarantee the tailored corduroy fabric won't slip, wrinkle, or shift off the T3208 PU foam cushions. This invisible layer of adhesive ensures the fabric stays perfectly taut and exactly where the designer intended it to be for the lifetime of the chair.
So, let's take a step back and see how this builds to our grand finale. We've watched this structural frame get assembled and screwed together. We've seen the seat and backrest cushions perfectly wrapped and glued. The final step at the workbench is joining those finished cushions directly to the wooden frame, resulting in a complete, ready-to-ship upholstered armchair.
Honestly, seeing a simple technical routing sheet brought to life completely changes how we look at a piece of furniture, doesn't it? From those aggressive 400mm saw blades to the precise CNC nesting, all the way to the heavy-duty polyester thread, it leaves us to appreciate the incredible, hidden craftsmanship and industrial engineering inside the everyday objects right around us. So what invisible manufacturing processes are hiding inside your own living room furniture? Something to think about. Thanks for joining me on this explainer, and I'll see you next time.